Hello, welcome to Pocket Ronnie. This is the very first lesson in the geometry book of Matthew C. curriculum, and we're going to be talking about points, lines, rays, and line segments. Geometry is full of definitions, and so it's really important to know what everything is. So we're going to start off with a point. So in geometry, a point is the smallest unit of measure. If you're watching along and you don't have a vocabulary sheet, I would recommend you make your own and you write out the definition that a point is the smallest unit of measure. A point, it has a position, like on a graph. You can put it on a graph, but there's no measure to it. There's no length, there's no width. And usually how we write this is point A, or you'll just see the letter A, which means point A. Okay, the next thing in geometry is a line. A line is an infinite number of connected points. Let me say that one more time. A line is an infinite number. I can have a bunch of points, and then if I just put them all, an infinite number of points together, I have made a line. So on any line is an infinite number of points. On this line, I only have 2 points labeled, but there is an infinite number of points on that line. So, and then we can call this line AB, because those are the points labeled on it. This symbol above your AB is very important. The line with the arrow on both sides means a line, because a line goes infinitely in both directions. So this line could be called line AB, or it could be called line BA. Either labeling is acceptable. Our next definition is collinear. Collinear are when 2 or more points are contained on the same line. Up here, points A and B are collinear. They are on the same line. It's when 2 or more points are contained on the same line. Okay. The next definition is ray. Ray looks like this. The difference between a ray and a line. A ray has a starting point, or what we call an end point, or origin. There's several different ways you can call it. It's a starting point. And this point is either called the end point or origin. And then it goes infinitely in one direction, as opposed to a line that goes infinitely in both directions. Okay, so a ray has a starting point, which we call this the end point or the origin, and we label this as ray CD. On a ray symbol, the arrow is only on one side, normally on the right side, and this is very important that this letter, the first letter, is your starting point, your end point, your origin. This cannot be called ray DC. No. You start your ray, you start your letters with the end point. The end point here is your starting point, C. So you say ray CD, and it goes infinitely in that direction. Also, in a ray, there's an infinite number of points. Since this goes infinitely in that direction, there's an infinite number of points. Our next definition is a line segment. A line segment is a finite or measurable piece of line. It is a segment of a line. It has a starting point and an end point. So here we use the symbols. This would be called line segment LH, and we use our symbol with just a bar with no arrows. This also could be called line segment HL. The ray is the only one that you cannot flip your letters around. Okay, definition of congruent. Congruent means exactly the same. It's the same shape and the same size. When something is congruent, it is exactly the same. This is the symbol used for congruent. When we use congruent when we talk about figures and shapes. A line segment are all considered figures. So when we talk about line segments being congruent, we use congruent. We use equal. We use that when we are talking about numbers. Congruent is used when we talk about figures and shapes. Equal is used when we talk about measures and numbers. Okay, the definition of similar. Similar means It's the same shape, but not the same size. So this triangle is similar to that triangle. They're the same shape, but they are not the same size. The symbol for similar is just one little squiggly like that. Okay, our last definition, AB, this means the distance from A to B. Notice there is no symbol up here. There's no line segment symbol, a line symbol, a ray symbol. When there is no symbol above your letters, this means the distance from A to B. So let's say we had this line segment of AB. When we just say AB, we're talking about the distance from A to B. We could say the distance from A to B is equal to the distance from B to A. That is a true statement. So just know when there's no symbol, you're talking about the distance. Alright, we're looking at page 1B, 15 through 20, and these two figures go along with these questions. Okay, the question number 15 says, what point is collinear with A and B? So looking at this figure, what point is collinear with A and B? Remember, collinear means they lie on the same line together. So the point that is collinear with A and B is point C. Number 16, it says point D is the end point of what? So right here, point D is the end point of ray DE. So that would be ray DE. Remember, the symbol up here is important, and it's important for D to be the first letter because that is the end point of the ray. D is the end point of ray DE. Number 17 says, this is line segment BC. The symbol is line segment. Line segment BC is contained in which line? So here is line segment BC. That area right there is line segment BC. It is contained in the line. There are several different answers you can have for that. It's contained in line AC. You can also call it line AB. You can use any 2 points on this line since a line goes infinitely in both directions. You could call it line BC, as long as you have, and you can flip the order. This could be line CB, line BA, line CA. So that line segment is contained in that line. Number 18 says, give a point that is contained in ray CE. Okay? CA, ray CA. So ray CA means the ray starts at C and goes toward A. So if it starts at C and it goes toward A, so you want to name a point in there. So one of those, you could name the point of B is in ray CA. The point A is in ray CA. And also point C is also in ray CA. So you could have named any of those points. Number 19 says, how many points are contained in line AC? Okay, we're going back to just looking at the blue line, not the red, the blue. How many points are in lines AC? Don't be tricked that you see A, B, and C labeled. Those are the only points that are labeled. Remember, there are an infinite number of points in a line. This line is made up of a bunch of tiny points connected together. So how many points are in line AC? I always just like to use the infinite symbol. There's an infinity number of points, an infinite number of points. Or you can write the word infinite number of points. Number 20 says, ray AB, this is not line AB, ray AB travels in the opposite direction from which ray? Okay, ray AB starts at A and goes forever in that direction. There's your A, there's your B, and it travels in the opposite direction of which ray? Well, you can have possible answers. There's several possible. It goes in the opposite direction of B, A, if B starts there. So I can say ray BA if it starts at B and goes towards A, or maybe it starts at C and goes towards A, or I could say ray CA. The main thing is it starts at the other end. Here it starts at A and goes infinitely to the right. Now I need to start over here and go infinitely to the left. Okay, now let's look at here. This is at 1C8. They want to know, how does this read? When you see it like this with all these symbols, how does this read? This reads as line AB, because the symbol is a line. Line AB is congruent to line BC. It's important to use the right words with the right symbols. Line AB is congruent to line BC. Alright, now looking at 1D number 12, same thing. How does this read? Remember, when there are no symbols above your letters, that reads as the distance from A to B. So this reads as the distance from A to B is equal to the distance from C to D. Okay, now let's look at 1D, 15 through 20. They're asking you to put true or false for these statements. We're looking at this figure. So one of the important things in geometry is to always read the given. In geometry, you cannot assume anything. So you always read the given of the information they tell you. And in the given, it says line AD, which is this line right here. Line AD is a straight line. So they're telling you that this is a straight line. So number 15 says, remember we're trying to say true or false. 15, B is collinear with E and A. Collinear means on the same line. Is B on the same line as E and A? No. So B is not collinear with E and A. So that statement is false. Number 16, this is line segment. That symbol is line segment. Line segment BC is contained in line AD. Line segment BC, this line segment right here is line segment BC contained in this line. Line AD represents this entire line. This line could be called line AB. It still represents, remember, a line goes infinitely in both directions. So even if this line was called line AB, then it's still contained in that. This line could also be called line AC, and this line segment would still be contained in that. So this line AD has many different names. It could be called line AB, and that would still represent the same line. So, but yes, line segment BC is contained in this whole line. So that statement is true. Now number 17. Okay, making sure I copied the problem correctly. Is line segment AB is included in ray BD. So line segment AB, let me go back to our original picture. So line segment AB. On some of these, it's good to have colored pens and pencils or colored to use to help you. Line segment AB is that line segment right there. Is that included in ray BD? Ray BD means it starts at B and goes toward D. Starts at B and goes toward D to the right. So therefore, this blue line segment would not be included in that, because ray BD would be this black line right there, and this blue line is not included in that ray. So that statement would be false. Now number 18 says a common endpoint of ray AB and ray BC is B. I can even look at that. I don't even have to have a picture to tell me that that is false, because ray AB, when you see it like this, the first letter is your endpoint. A is my endpoint. Ray BC, my first letter is my endpoint. So B would be my starting point going towards C. A is my starting point going toward B. They have different starting points, so therefore they do not have a common endpoint of B. This one has the endpoint of B, but this one does not. So that statement is false. Now looking at number 19, line segment DF is congruent to line segment FD. Well, if you look in your picture, this blue line right here is line segment DF. Is that the same thing as line segment FD? Yes, it is. When you're talking about a line segment, the letters can be flip-flopped. They can be exchanged. That's not the word I'm looking for, but yes, they can be written like that. So line segment DF is the same thing as line segment FD, so that statement is true. Looking at number 20, a straight line could be drawn with E and F collinear. Here's E and here's F. The kicker word, and you have to watch this a lot in geometry, are words like this. Could. A straight line could be drawn with E and F collinear. There is not one drawn, but could there be? Yes, there could. When you're dealing with lines and points, you only need 2 points to draw a line. A line does have an infinite number of points, but you only need 2 to draw a line. So if you have point E and point F, yes, you could draw a line to where they are collinear. There is not one shown on the figure, but one could be drawn. So be careful of words like that. And so yes, that statement is true.